In this video, I will explain how to use the software in the loop with realflight for the INAV debugging. And here is the main procedures. First, we need to get a build INAV SITL firmware. And we can get our firmware from the official INAV repository. And we click the actions here. And we go to find the firmware we want. For example, I have choose my pull request, and this pull request is for the Vito. And we go to the artifacts at the bottom here, and we can download the software in the loop firmware here. For the official release of the SITL firmware, you can find the firmware in the official release of the INAV configurator. And I have already downloaded the Linux version of the INAV configurator here, and we look into the resources and for the folder SITL Linux, and we can find the INAV SITL firmware for the Linux to use and also for the Windows. And I have found the SITL for Linux is more stable than the Windows version, so I will use the Linux version for the development. And or you can follow the procedures to build the SITL firmware by myself from the official INAV document. SITL, and the procedure is shown here to how to build your own firmware. And in my folder here, I have already built firmware, which is this one. In case you have downloaded your firmware from the internet, you might need to change the permission to make it executable. The next step is to get the realflight simulator. I downloaded it from the Steam. And the next procedure is to get the models for the realflight. And I get my models from the audio pilot repository, SITL models. Click the realflight and the released models, and there are multiple models, including the Vito or the multicopter or normal planes. And here I will use the multicopter for example. To click the quadcopter X, and we download this RFX archive file. After that, we go to the realflight and my realflight, import realflight archives, and we select the archives we have just downloaded. And we also need to enable the Reallink settings, physics, quality, realflight link enabled. Select enable and restart the realflight. And for the next step, we need to start the simulator. We just click fly here, and we need to choose our aircraft. For the aircraft here, just choose the model or the aircraft we just imported from the archive file. And there's another important point is to choose the correct airport. There's two kind of scenario in the realflight, and one is the photo field, and another one is the 3D. Make sure you have to choose a 3D airport type. And you can press C on your keyboard to change the views. And also we need to set the radio controller for the simulator. And the settings here, controller, and configure controller. And I have my Radio Master TX12 configured like this. And the next step is to start the INAV firmware. First, we have to start the realflight first. Then we start the SITL firmware. And we can use this command to run the firmware. With --help, we can display available options. And here's the command I use for this example. The EPROM save path is this, and the simulator is the real flight. And the channel map is to map the motor 1 to input 1, motor 2 to input 2, motor 3 to input 3. And for this channel map, you can find the definition of the input in the real flight SITL models repository, like here. The input 1 is for the motor 1, and the INAV motor 1 is for the input 1. That's for the motor 1 in the real flight model. And for more complicated models like this VTOL model or the quad plane models, there is more mapping that we need to do. And first, it's the same. We look at the AudioPilot for server functions or the input mapping here. The input one is for the aero, and this is for servo. And the input 2 is for elevator, and this one is also for servo. And the input 3 is for the throttle, so this one is for the motor. And in the INAV firmware channel mapping, the INAV servo 1 is mapped to the input 1. The INAV servo 2 is mapped to the input 2. And the INAV motor 1 is mapped to the input 3. The input 1 and 2 is for servos, and the input 3 is for the motor. The input 4 is also for the servo. And next we have to look at the input 5, 6, 7, 8. And these inputs are all for the motors. So in the following command here, we map the INAV motor 2 to input 5. And since we are running the formula in the Windows subsystem for Linux, so we also need to specify the simulator IP, which is this. And you can get your host IP using this command. And this one is the host IP. It's the Windows IP. We paste the host IP, this one, to the simulator IP here. And we press enter to start the simulation. And from this point, we can use the INAV configurator to connect to the SITL firmware running in the Linux subsystem. And the IP and the port for connection is the localhost at port 5760, and to select the TCP for the connection. And in the configuration tab, we need to select fake, accelerometer, magnetometer, and barometer. And for the receiver, here we need to select the receiver mode as the simulation SITL. And for the OSD function, I have enabled the MSTP display port on UART4. And use the INAV configurator to finish the rest of the settings. You can use the Output tab to manually move the motors. Here in the simulator, the motor 1 is spinning here. And for the motor 4, it's spinning here. The motor order is in the audio pilot order, in my case. So the motor number is shown in this picture, motor 1, 2, 3, 4. Sometimes we got the segmentation fault problem, and in this case, we just need to restart the firmware again. I will copy-paste my pre-configured CLR files to speed up the settings. The next part is to enable the OSD in the simulation, and for the OSD program, we can find it in the document file. Here, OSD, in this repository. And we just download the latest release. And we also need to specify the IP address and the port to connect to the firmware in the software in the loop. And from our settings, we have set to the OSD to the UART4 and it's bound to the TCP port 5763. And for the IP address, we need to get the IP address for the Linux subsystem, and we can use the ifconfig command here to get the IP address for the Linux subsystem, and we copy paste this address to the IP port here. And after that, we click the start, and we can see the INAV OSD showing up. And we can fly our drones or planes in the simulator. You can press space to reset your model to repair and reset it to the home position. That's all for the instructions, and I'm still looking for a way to enable the black box logging. Thank you very much for watching, and thanks to all developers who have developed this software in the loop feature for INAV.